Hey everybody, this is Games Plus James, and welcome back to our Unity RPG tutorial series. Now, in this episode, we're going to start looking at how to add some NPCs into our game, some non-player characters. So this is going to be the start of a new kind of like aspect of this series. We're going to add a basic bit of character movement here in this episode, and we're going to start adding things like dialogue and quests and an inventory system to the game to make it all feel more and more like an RPG game. So we've lots more to cover in this series and plenty more to see and learn along the way. Okay, so we're going to add just a nice simple little villager movement system, because people have been asking me about the way our slimes move about in the world. It can seem a bit random with how they kind of move diagonally, sideways and stuff like that. So people were asking about how to make it so that movement only goes up and down or left and right. So we're going to do that with our villager here in the village. So I've made this simple little kind of village map, not too complicated, the exact same way we've made our maps previously in our game. So next thing we need to do is actually have some villagers to be able to use. So I'm going to drag a new art file in that I've just added to our resources for the series. So this will be the one here. We're going to make sure that this is set up the same way as our normal character is. So the same size, pixels per unit is 16. We want multiple sprites. All of this stuff the exact same as we have on our normal character here. We don't need to generate maps. We'll hit apply, and then I'm going to open the Sprite Editor. So you can see there's just these four kind of basic looking characters. Not too complicated. Like I said, we just want to get the basic movement of all this down to understand how it works, because we've covered how to do animation and stuff. If we wanted to make a fully animated villager, we'd essentially do the exact same thing we did with the player, but just applying it to the villager. So we're not going to go through doing all that again. We're just going to focus on how they actually move around in the world. So I'm going to split this up, and rather than having to do it by the exact size of them, we're going to do it by the cell count. So we know we have one row of all these guys, so we leave that at 1, and we've 4 columns, so basically 4 vertical splits. So we'll say 4 columns, 1 row, hit the slice, and it automatically chops them all up nicely for us. So we'll apply that. Then we're going to drag 1 into the world here, so we'll grab, just say, this red top guy, and if we zoom in we can't see him because of obviously how we've set up our layers and stuff. So on our sorting layer, we're going to go over here and set that to be player, and we'll leave it at 0, so he'll appear actually behind the player in the world if the player happened to walk over him. So let's give him a box collider so that he can hit off buildings and things like that, and we'll also give him a rigid body so that we can move him around in the world. Rigid body 2D, and we want to make sure that his gravity is 0, much like we did with other stuff, so that when the game starts running he doesn't just fall off the screen, which wouldn't be much use to us at all. Okay, so we've got our base little villager set up, so let's actually go ahead and give him a script. So we'll go to our scripts folder, and we're going to create a new C# script that we will call villager movement. And then we're going to open this up here in MonoDevelop. Okay, and once this is open, we're going to need some basic movement stuff to be able to move this player around in the world. So obviously we'll need a speed for him to move. So we'll need a public float move speed. We'll obviously need to make a reference to his rigid body so that we're able to move him around. So we'll say a private rigid body 2D that we'll call my rigid body. And much like we've done before with rigid bodies, we want to make sure that in the start function we assign that straight away. So we'll say here our rigid body is equal to get component rigid body 2D, like that, so that we know we're finding the exact right thing on our villager. So we'll also need we need to know whether the villager is currently walking or not, much like we did with our slimes when we were moving them around. We want to be able to determine whether he's moving and how long he should stay moving and stay still. So we'll need a bool to say whether he's moving at the moment or not. So public bool is walking. We need how long he should walk for and how long he should stay still for. So we'll say a public float walk time, and a public float wait time. Oh no, I spelled that wrong. Wait time. There we go. And obviously, to keep track of these values and to count them down over time, we'll need to use a counter so that we're not just counting down our original values. So much like we've done before, again, not a public float. We'll make this private so we don't actually we're not actually making changes to it in the game. So we'll say a private float walk counter and a private float wait counter. Okay, so in our start function here, we'll obviously want to make sure that to start off with, our wait counter is equal to our wait time, and our walk counter is equal to our walk time. So by default, our is walking will be false. So our player will start off, or sorry, not our player, our villager will start off not moving. Okay, so we've got the basics here. But now we want to decide how are we actually going to decide which direction our villager is moving. So I'm just going to save this, convert that, go back in here. I'm going to put this script on our villager because obviously we need to be able to control him. So our villager movement. We'll fill in these values here. If we can just scroll down, there we go. So I just give him move speed 2. He can walk for 1 second and stay still for 3 seconds. Okay, so we know we want him to move either up, down, left, or right. So we know that we're just dealing with 4 different values there. There's up, right, down, left. So if we were to treat it as, if we were to just conceptually say, okay, if we give all the directions a number, so if we start at the top like a clock, if we say up is 0, right is 1, down is 2, and left is 3, then we have 3 different numbers that we can use to determine which way we're going. And so we know we've used before that we can randomly pick a number. So if we just randomly pick a number to represent one of those 4, then we know that we have a direction chosen, and then we can actually use that choice to control how our player moves. So let's do that. Let's go back into our script. If we're going to choose a direction using a number like that, we'll obviously need to have a number to use. So we're going to create a private int called walk direction. And then down below our update, we're going to create a new function down here that we're going to say public void choose direction. So this is what we're going to use every time we want to choose a new direction for the player to go. And basically all we're going to do here is just say that our walk direction should be equal to random dot range between 0 and 4. Now the reason we pick 4 is because we're dealing with ints, and the way random.range works is if we use floats, and if we were to use floats and say it was between 0 and 4, it would pick any number between 0 and it could be any decimal point value all the way up to 4, and it could include 4. But because we're using ints, it will never pick the top number, so it'll always either be 0, 1, 2, or 3. And like we said, as we were describing the kind of hands on the clock, we're saying 0, 1, 2, 3 are the values that we want. So we don't, obviously there's no 4th value. We don't want our player kind of disappearing into the ground or up into the sky or something like that. So what we do want then is it to pick a number between 0, 1, 2, or 3. And once it's picked that number, we also want to say, okay, so now that we've picked the direction, obviously we want the player to start moving. So we'll say our is walking should be true. And just every time we set our is walking to be true, we want to make sure that our walk counter is being reset to its full value. So at the same time, we're going to say walk counter is equal to walk time. So logically, as soon as the game starts, we really want to actually choose the direction straight away for our player to start moving in. So at the end of our start function, we're going to add in here just a call to run our choose direction function down here. So as soon as the game starts, it'll set all this stuff the way we want, and then it'll choose the direction like this, and then we'll start going into our update loop. So in our update loop, obviously we need to know if we're, to start off with, if our player is moving or not. So if is walking is true. Is walking. So if is walking is true, then we're going to do some stuff here, and then we're going to add down below else, then we're going to do some other stuff. So basically, if our player is walking, then we want to do a whole bunch of stuff, and if the player is not walking, then we want to do some other stuff. So if we're walking, so as long as we're walking, we know we want to keep counting down our walk counter. So our walk counter minus equals time dot delta time, and then if our walk counter gets, oh sorry, that should be an if statement. So if our walk counter, if that becomes less than 0, then we want to stop walking. So we'll say is walking equals false, and we want to reset our wait counter so that we can start waiting however long we have to wait before we start moving again. So wait counter now is equal to wait time. So at that point then we would switch over to this part. So in our else statement here, our is walking is false, and our wait counter should now be counting down. So wait counter minus equals time dot delta time, and then if our wait counter is, oh, again that should be an if statement, what am I doing? If our wait counter is less than 0, then at that point we'll want to start walking again. But rather than doing setting our walking to be true and our wait counter to wait time, what we'll actually want to do here is choose a new direction for our player to walk. So we will call our choose direction function here. So we will say choose direction and our 2 brackets, and then it'll go down here, pick a new direction to walk in, and it'll set the walking as true, and a walk counter is equal to walk time. Okay, so that's the basic logic of all that stuff kind of set up, and that's absolutely fine, and that'll all work well for us. But what we want to do now is actually control how we're moving in the world. At the moment, all that's happening is we're switching between these 2 statements. So if we know that our walk direction can be only 4 different values, so it can be 0, 1, 2, 3, or 4, what we could do, like, for example, if we could say if walk direction equals 0, then we could do we can put a bunch of code in here. Then we could do if walk direction equals 1. We could do a whole bunch of code, but that's not very efficient. It's kind of, if you were to do that a lot in lots of various scripts, it kind of would start bogging down your code quite a lot. But instead what we're going to use are switch statements. And I don't think we've covered them in this series so far, but basically a switch statement is you give it a certain variable to look at, and then it'll go, okay, based on that variable, we have a whole bunch of different options that we can do. So what we're going to do is we're going to say switch, and then in a bracket, we're going to say walk direction. So basically what we're saying, we're going to do a switch statement, and we're going to use our walk direction variable to control it. And then we put some open and close brackets like that. And the first thing we do is type in case, and then 0, and a colon like that. So what this means is, in the case that our walk direction is 0, then we'll do a bunch of code in here. So we will tell it to do something. And then once we finish telling it to do something, what we'll have to do here is say break. So break just means we're at the end of handling this little bit of case, and you can stop doing stuff in the switch statement basically, because the next line we'll put down here is case 1. So what we're saying here is if our walk direction is 1, then we'll jump straight to down here, we'll do our little bunch of code, and then again we'll have a break like that, and this, so it'll jump and stop running the switch statement. So basically if our case is 0 here, so if our walk direction is 0, it'll do our whatever little bit of code we put here, then it'll get the break and it'll say, okay, now stop running because case 1 isn't true or all the other cases aren't true, so we don't need to worry about them. So we know that we've got case 0, 1, 2 and 3 are the 4 different values we could possibly have. So let's just copy this, paste it there like that. So we'll change the 1 here to 2, and then we'll paste one more in, and we'll change this to 3. And so we know we have our 4 different situations for whether our player can be moving. And how are we going to control our player movement? Well, we know we're going to use our rigid body, much like we've done before. So we're going to say on our rigid body, my rigid body dot velocity is equal to a new vector 2. So if we're thinking again of our numbers as being on a clock, we have 0, 1, 2 and 3. So 0 is going straight up. So now we know that we want to make our velocity go straight up. So we're going to have our x value be 0 because that's going left to right, and our y value will just be equal to our move speed. So we can do the same in case 1. So we'll say my rigid body dot velocity. Actually, rather than typing it in every single time, let's just copy this line here, paste it in, and this time, instead of it being our x value is 0, because we're at case 1, so we're at moving to the right on our clock, so we know that we should have our x value should now be equal to our move speed, so that we're moving to the right, and our y value should be 0. Then in case 2, we're going to say, okay, at this point we want our x to be back to being 0, but we want our move speed now to be minus move speed, because case 2 will be moving down, and then finally case 3 will be moving to the left. So we're going to have the x value be minus move speed, and the y value will be 0. Okay, so we're going to just save that. And then one final thing we want to do is make sure that when we are waiting, so we're no longer walking anymore, we want to make sure that our move speed is always 0. So here we're just going to say my rigid body dot velocity equals vector 2 dot 0. So that will just make sure that our x and our y values of our velocity are both 0, so we don't need to worry about them too much. So we'll just save that. And actually, just looking at this, I want to move this the walk counter check here. We want to just move this down so it's below our switch statement. So we do that check after we set our player moving in the world, because we want the last thing to do to be this, so then it immediately switches over to our waiting value here, rather than trying to switch over and then running the switch statement. It wouldn't really make a huge amount of difference, but just kind of logically for our own selves, we want to keep it nice and simple. Okay, so we're going to jump back in here now. And once this compiles, we should see that our player, our villager, should be constrained to only move in our 4 directions within the world. So if we, there's no other values, we set up our values down there. So if we hit play here, we'll jump into the game view and it'll be kind of awkward to see. So I'm just going to switch back to our scene view, and we should see this guy. There we go. He moves a little bit, waits for a little bit, then he moves, and you can see he's moving only in straight lines every single time as he's moving around in the world. So it's a much more kind of sensible way of movement. So if I walk down here, so we can, oh well, I should have frozen his rotation, but you can see that he is actually moving around in the world, and we can kind of interact with him and push him around a bit if we want to. And if we didn't want to be able to push him around, let's go back to our villager. Let's just freeze his rotation. So if we were to make his mass, say 1,000, and hit play again, then our player shouldn't be able to move him around in the world, I don't think. Yeah, there we go. So his mass is too heavy, the player can't make him move. He can move by himself or whatever. But he's free to walk around the world as much as he wants. But if we were to, say, put his move speed up quite a bit here, suddenly he starts flying off all over the place. And we can end up with our kind of, our villager guy here, running out into the world, and he can be running off into all kinds of different places. So in the next video, we're going to take a look at how to make sure that our NPCs here can only stay within a certain zone. We're going to create basically a box that the NPC will be allowed to move around in, but it'll never be able to go outside of that box. So that's what we're going to take a look at doing in the next episode. Thanks for watching this episode, and if you want to learn more about developing your own games, you can follow the link on screen to my complete 2D platformer game development course on Udemy, where you will learn how to program and build a complete game in Unity 2D with multiple levels, enemies and unique boss battles. So click the link on screen or in the description below and get the course today.